In this lesson, we're going to cover how to solve inequalities using addition, subtraction, and multiplication. The essential understanding is that just like you used properties of equality to solve equations, you can use properties of inequality to solve inequalities. So let's begin with a couple of basic properties that we're going to be using. Here's box 1, called the addition property of inequality. And it's an if-then statement. And here's what I mean by that. So if we know that A is greater than B, so if I have two numbers and say that A is greater than B, then I'm guaranteed that if I add the same number to both sides, like A plus C, that's going to be greater than B plus C. So here's an example to illustrate this exact point I'm trying to make. So we know that 5 is greater than 2. Everyone agrees with that. Now, if I add 3 to both sides, right? So 5 plus 3, it's still going to be greater than 2 plus 3. So as long as I'm adding the same number to both sides, I'm still going to get a true statement. So obviously 8 is bigger than 5. So that's still a true statement. 8 is bigger than 5. That's what it's trying to make. Now, there's another one too. If I'm starting off with the fact that A is less than B, so A is smaller than B, then still, if I add the same number to both sides, A plus C is still going to be less than B plus C. This is why they call this the addition property, because we're adding something to both sides. So as a quick example, right, 5 is less than 7. So 5 plus 1 is going to be less than 7 plus 1. If I add the same thing to both sides, look, 6 is still less than 8. Box number 2 is the subtraction property of inequality, and it's going to work exactly the same way as the addition property started off. So let's begin. If I have two numbers, and I say that A is greater than B, then if I subtract the same number from both sides, A minus C will still be greater than B minus C. So as a quick example, here we go, right? We know that negative 3 is bigger than negative 5. So if I add 1 to both sides, or excuse me, subtract 1, negative 3 minus 1 should be bigger than negative 5 minus 1. And we can check and see negative 3 minus 1, negative 4, is still bigger than negative 6. This is still a true statement. Okay, similarly, on the other way, if I know that A is less than B, if I'm starting off that way, then I know that A minus C is going to be less than B minus C. This is why this is called the subtraction property of inequality, because we're subtracting the same number from both sides of the inequality. As an example for this one, right, I know that 10 is less than 15. So that means that 10 minus 3 should be less than 15 minus 3. And absolutely, 7 is less than 12. Perfect. Box number 3 are 3 examples I have for you. The directions say to solve the inequality and graph the solutions. So here we go. I know that if I have that x minus 15 is greater than negative 12, then I know that I can still add 15 to both sides and not change the direction of the inequality. So it must be true that x is still greater than a positive 3. And now I have an isolated inequality that's saying that x is greater than 3. So I'm going to graph this on the number line. Remember, as we saw in our previous section, I got to give you 0, got to give you 3, then I place an open dot above the 3 because I'm not including the 3, and I shade to the direction of the right. So I have solved and graphed the inequality. Let's take a look at part B. It says that n minus 5 is less than negative 3. Well, the addition property says I can add 5 to both sides. Okay? And I can see that n would have to be less than negative 3 plus 5 is a positive 2. And I have isolated my inequality, and now I need to graph the solution set. So I'm going to graph the number line. I'm going to give you 0. I'm going to give you 2. And I'm going to go above 2 and put an open dot and shade to the left. So any value that's in the shaded region will make the inequality true. Take a look at option C here, or example C rather. I have 2 is less than 9 plus x. I want to get x by itself, so I'm going to subtract 9 from both sides. 2 minus 9 is negative 7 is less than x, but I don't like writing it like this. I would prefer to have my variables on the right, or excuse me, on the left. So I'm going to rewrite this as x is now greater than negative 7. These are equivalent statements. Okay, and I want to graph this. So I got to give you 0, and I got to give you negative 7, which is to the left of 0. I'm going to put an open dot above negative 7, and I'm going to shade to the right. Because when I have my variables on the left-hand side of the inequality symbol tells me the direction to shade. We covered that in the last lesson. Box number 4 is a U-try. I would like you to solve the inequality and graph the solutions. Here's the solution. We've been given that 6 is greater than or equal to x plus 4. I'm going to subtract 4 from both sides and say that 6 minus 4 is worth 2. So 2 is now greater than or equal to x. I'm going to choose to rewrite that as saying x is less than or equal to 2. Then to graph the solution, I give myself a number line, I give myself 0, I give myself 2, and I place an open dot above the 2, and I color it in this time because it's less than or equal to, and I shade to the left. So any number that's to the left will satisfy the inequality. Box number 5 is the multiplication property of inequalities. So let's begin. Let's say I have 2 numbers, and I say that A is greater than B. And then I tell you that there's another number C which is greater than 0. So that just means that it's positive. Well, then it must be true then that if I multiply both sides by C, so A times C will still be greater than B times C. So let me give you a quick example of that. Okay? So it is definitely true that 5 is bigger than 2. We all agree with that. And I'm going to multiply both sides by 3. Okay? So I want to know 5 times 3, how does that compare to 2 times 3? Well, 15 is still bigger than 6. That's the first part of the multiplication property. That's what this part is trying to get you to understand. Now the second part is very, very important. The second part says this. Let's say that A is greater than B, but C is now going to be less than 0, meaning that C is negative. Well then, what we need to do is if we multiply both sides by a negative, A times C, we must reverse the direction of the inequality sign less than B times C. So let me give you an example of how this is working. All right? So I'll show you again. We all agree that 5 is greater than 2. But I'm going to multiply both sides by negative 3 in this case. So I want to see what happens if I take 5 and I multiply it by negative 3. How does that compare to 2 multiplied by negative 3? Well, negative 15 is no longer greater than negative 6. It's further away from 0, so I have to reverse the direction of the inequality sign. Notice that I started with a greater than statement and I ended with a less than statement because my C value was negative. So, very important, whenever you multiply or divide by a negative number on an inequality, we reverse the direction of the inequality sign. Box number 6, I have 3 examples to illustrate the multiplication property of inequality. The directions say to solve and graph the solution. This says x divided by 3 is less than negative 2. Well, I'm going to multiply both sides by 3 to isolate x. So that tells me that x is now going to be less than negative 6. I do not need to change the direction of the inequality sign here because I'm multiplying by a positive number, and that number is 3. So therefore, I graph my inequality, I graph my solution, I give you 0, I give you negative 6, and I put an open dot above negative 6 because it is strictly less than. I'll erase that for you so you can see. And I shade to the left. That's how we would do part A. Let's take a look at part B. Part B says negative 3 divided by 4x is greater than or equal to 3. I like to rewrite this as negative 3x over 4 is now greater than or equal to 3. Because now I can use the multiplication property. I'm going to multiply both sides by 4 to isolate my x. Multiply both sides by 4. This gives me 3x is now greater than or equal to positive 12. Oh, excuse me, negative 3x is greater than or equal to positive 12. My next step is to divide by negative 3. Divide by negative 3. So because I am dividing by a negative number, I could interpret that as multiplying by 1/3. So therefore, I must reverse the direction of the inequality sign. So x must be less than or equal to 12 divided by negative 3, of course, is negative 4. So graphing that on the number line, here is 0, here is negative 4. We put an open dot and we close it off because it's less than or equal to, and I shade to the left. Here's example C. It says negative 9y is less than or equal to 63. In order to isolate the y, I'm going to divide by negative 9. I'm going to divide by negative 9. Because I am dividing by a negative number, I must reverse the direction of the inequality sign. So y must be greater than or equal to negative 7, because 63 divided by 9, negative is negative 7. I then graph the solution set on the number line. I put 0. I put negative 7 to the left of 0. I put a closed dot because it is greater than or equal to, and I shade to the right. Box number 7 is a U-try. I would like you to solve and graph, and please be very careful because the variable is on the right hand side. I like to rewrite my problem. Negative 5 is greater than or equal to negative 5x over 9. Then I'm going to multiply both sides by 9. 9 is a positive number, so I don't need to worry about reversing the direction of the inequality. So I'm going to get negative 45 is now greater than or equal to negative 5x. I am now going to divide by negative 5 on both sides. Negative 45 divided by 5, of course, is positive 9. So 9 is now greater than, or excuse me, because I divided by a negative 5, I need to reverse the direction of the inequality sign. So 9 will be less than or equal to positive x. Now, because my x is on the right-hand side, I would prefer to write my equation as this. X is now greater than or equal to 9. Do not mistake this step for me reversing the direction because I multiplied or divided by a negative. It's simply an equivalent statement. Now, to graph my solution set, I graph a number line. I put 0. I put 9 to the right of 0. I put an open dot and then close it above number 9, and I shade to the right. Hopefully you got that answer correct.